I will not be doing a video on fixed SSD calculation techniques or single field SSD calculation techniques. They're pretty straightforward. You can read through them in Bentel. You hardly ever use them for photons. Most people don't have superficial machines anyway, although it's an easy calculation to do, and electrons we already went over. What I do want to concentrate on is SAD techniques, okay, source to access distance techniques, because the majority of linear accelerators that you are going to eventually go get a job and use will be SAD calibrated machines. Okay, they're going to set an isocenter in the patient, and the machine is going to rotate around that patient while the patient lays in the treatment position. Okay, we're not going to be flipping patients over and treating AP and separate PA fields at 100 centimeter SSD. Okay, so most bang for your buck is let's concentrate on SAD technique. The first thing that we need to talk about before we do any examples is how's the machine calibrated. Machine that we're going to be calibrated today, or that we're going to be using, 6X, is going to be calibrated at 1.5 centimeter deep for a 10 by 10 centimeter squared field size at 100 centimeter SSD. Okay, it's going to deliver 1 centigrade equals 1 mu. That's how our machine is going to be calibrated. Okay. I have uploaded, at the time of this video they're not yet, but I will upload some of our data book pages from here. It will have 6x, 15, and 15x, both percent deptose and TMR tables, as well as electron percent deptose and output data, as well as electron deptose curves. So any and all examples that I'm going to be using in these podcasts the data is going to come from those, so you can follow along. For 15x, I'm calibrated at 2.8 centimeters, 10 by 10 centimeter squared field size, 100 centimeter SSD, 1 centigrade equals 1 mu. So for all podcasts from here on out, this is the machine calibration that I'm using. At your particular center, pay very close attention to the type of calibration that they have. They might be calibrated at 100 centimeter SAD instead of SSD. That's another common calibration. Usually it's one of the two. Maybe they're calibrated to deliver 1 centigrade per monitor unit at a different depth. So talking about APPA setups. APPA setups are excellent because they're fast, they're easy for the therapists, the calculations are simple, and the physicians, it's hard to miss your target when you're using an APPA setup. So it allows for a more lax demobilization. So example 1 is, if I have Isocenter in the center of my patient, and I have APPA fields, patient thickness is 20 centimeters, which makes each of my depths for my beam 10 centimeters. Most of the time we put Isocenter mid-plane, because that way we don't get any sort of magnification between the jaws. Field sizes are defined at ISO, so my field size for my AP and my PA should be the same since my target's located at Isocenter. Okay, this makes the dose calculation easy. This makes reviewing port films easy. Jaw sizes will be the same. So if I am delivering 180 centigrade at ISO to the 100% isodose line, okay, how many monitor units do I need from each field? This field is going to be a 12 by 16, and this field is going to be a 12 by 16. So almost everything's identical. So we're only going to have to do one monitor unit calculation. Okay, so when we talk about MU calculations, we have MU is going to be dose. We are going to need collimator, phantom scatter, TMR, in an isodose line. We will not need an O and an inverse square factor. We do not need a wedge factor, we do not need a tray factor, and we do not need an off-axis ratio. We don't have a wedge, we don't have a tray, and our calc point is not off-axis. Remember, the name of the game is we're prescribing 180 centigrade to this exact point. because we prescribe 180 centigrade to this point and we deliver monitor units through these fields, my isodose lines are going to look something like this. Where my 100% line bows in and my 95% line is straight. Alright, so let's plug and chug. If I have equal weighting, 50% of the dose goes to each of them, so I have 180 centigrade times 0.5, right? Or I could just say 90 centigrade from each beam is going to deliver 90 centigrade from the PA here, 90 centigrade from the AP here, gives me 180 total centigrade. If I forgot to mention my beam energy, it's 15x for each beam. So if I look at my 15x data tables, okay, I need to do equivalent square, 12 by 16. So I have 2 times 12 times 16 plus 12 plus 16. What does that give us? 2 times 12 times 16 divided by 28 gives me 13.7. So I'll say 14 is my equivalent square. I look up S sub C for a 14 field size, and it's right around 1.018. I look up S sub P for a 14 field size, and it's right around 1.006. I look up TMR for a 14 field size and a depth of 10. And my inverse square law for this, because I'm calculating to a point at 100 centimeter SAD, but my machine is calibrated at 100 centimeter SSD plus 2.8, I'm going to get 102.8 divided by 100 squared. Okay? So let's plug and chug through this. So I get 90 divided by 1.018 divided by 1.006 divided by 0.88 divided by 1.057 gives me 94 mu. This equals mu from the PA. So each field I'm delivering 94 mu to deliver 180 centigrade at Isocenter. Now, let's say my target's a little bit big. Let's say it comes out here outside the 100% line. The doctor comes in, looks at your plan and says, hey, you know, I don't really have 100% coverage on my periphery. You know, the 100% line bows in. I need to prescribe down to the 95% line. So how do we modify the equation? Well, now we'll put in a normalization factor for here. So now my equation, I'm going to throw in, if he wants to prescribe at the 95% line, 0.95. Smaller number on the denominator makes the monitor units go up. So I take 94 divided by 0.95. My new monitor units are then 99 mu. So I normalized to a lower isodose line. I've now pumped 5 more mu in from each beam to make my 100%, my 180 centigrade line, come out to cover the edge of the tumor.